Hello and welcome everyone. In this lecture, we are going to talk about microservice communication in ASP.NET 5 with RabbitMQ. Now, this is part 7 of my present series of microservices. Now, if in the last lecture, I have talked about building a Hello World application with ASP.NET Core console application, and we had seen two projects, send and receive, and you if you keep the send project running, and it can send the message which is received by the receive project, which is acting as a consumer to the publisher, which is the send project. Now, if you haven't gone through this, I strongly recommend you go through this, where I have actually talked about the message broker concept and introduced about the RabbitMQ, and the description of that video is in the YouTube video description. I have sent a link in the video description, so please go through it. And I have talked about the uh, Docker container running the RabbitMQ environment, which is the easiest way to create a RabbitMQ environment. And in this project, in this tutorial, I am going to talk further about the how actually the product microservice will talk with the customer microservice, which is a um, pub sub, or product being the publisher and the subscriber being the customer microservice. So here you go. So let's see what we are going to learn today. So the learning outcome is adding a shared model library to the existing solution, which will do the first thing, and making the product microservice as the publisher, and introducing MassTransit and in the new concept as the Rabbit message queue abstraction layer, and installing the required MassTransit package, and configure MassTransit in the product as the publisher, and configuring the MassTransit in the customer, which is going to behave as a receiver or a consumer. And finally, we'll test the communication between the publisher and the consumer microservice using Swagger UI rather than using Postman. Okay, so we are in for a very interesting session. So please go through the entire tutorial and you will get the best out of it. And I have also made a blog out of this tutorial, which will be in the description of this video. So let's switch over to Visual Studio. So friends, I will take this existing solution, which we have, if you have followed my other 6 tutorials, you would have seen how I have built it from scratch. This microservices.web API, it contains now 3 projects: a customer microservice, a product microservice, and a gateway.web API, to which I am going to add a 4th project, which is of .NET Core library. So add a new project, and this time I'm going to click class library, which is a project for creating a class library that targets .NET Standard and or .NET Core. So click on next, give it a name, shared.models, and click on next. Now you can see here there is an additional information which gives the target framework. So I am persisting with the .NET 5, which is the current platform, and click on create, and it will create the shared models folder. Okay. So guys, now we have got 4 projects, and in the shared models folder, I will create a new folder and add a new folder and name it models. Okay. And I will get rid of this default class. So I'll just delete this. Okay. And then in this models class, I'll create another class. So add and name this customer product. Click on add. It will create the customer product class, make it public. So what I will do, I will just get rid of the existing code, default code, and copy over the code that I had on my clipboard. Now this is a customer product class, and it has got the product name and a date time field added on date, product description, and a price, which is a decimal. Now what my intention is to create a new product for the um, by the product microservice, which is going to act as a publisher or a sender of a message, creator of a message, which will be um, consumed by the customer microservice. Now, this will, whenever a new product is added, that will be notified to the customer microservice, and customer microservice will subscribe to that message produced by the product microservice. And that's what we are going to learn. Now, next, I'll have to actually put the reference to this shared models library for this customer and the product microservices. So right click on add project reference. So in which I will add this shared.models and click on OK. This is for the product microservice. So it has got a reference added now. So project shared.models, and similarly we'll do for the customer microservice. So this is dependencies, right click, add project reference and shared.models, click on OK, and there you go. You have got the shared models library, which is now on this customer and product microservice are both sharing the dependency for this shared model, which will be used as we'll see later. Now, as I have said previously, that in our requirement, the product microservice is essentially the publisher that sends a notification to the queue of the RabbitMQ. So whenever a new product is added to the database, the customer microservice will be the consumer who will subscribe to the notification and consume the message when the customer microservice is online. Now we can see here that I have already logged in with the RabbitMQ with the guest credentials, user guest, and the password is also guest. And this is it is running on the localhost port number 15672, which is the default port on which the RabbitMQ runs. And you can see that there are no queues, all queues 0, and there are no exchanges. We haven't introduced the concept of exchange, but just bear in mind there is a concept, advanced concept of exchange for this message broker service, and there are no queues, no connections, 0 connections, and no channels. So now we'll actually populate all of these with our project. So next come the concept of Rabbit as mass transit. So mass transit, what is mass transit? It is an abstraction layer on top of RabbitMQ for .NET. So though we have uh, a few hooks in the RabbitMQ library that permits us to communicate in a raw fashion, we can still be better off by using an abstraction layer, which helps us in doing the dependency injection, doing the unit testing, and many other features that the .NET affords by using the mass transit NuGet package. And it's a nice layer of .NET friendly abstraction over the message broker service, whether it is a RabbitMQ and or Azure Service Bus or any such, which is compatible with .NET. To meet this goal, it brings a lot of application specific logic closer to the developer in an easy to configure and understand manner. And it is also free and open source distributed application framework for .NET, and it is easy to create applications and services that leverage message based loosely coupled asynchronous communication for higher availability, reliability, and scalability. And it has got a extensive set of developer friendly features to build durable asynchronous services. Okay, and it adds the following prominent features, which are the concurrency and exception retries, serialization, message header and correlation, routing, and of course unit testing and connection management. Now for installing the required mass transit package, I will actually open up our tools and NuGet package manager console. So I'll have to install these packages one by one on both the microservices, which is the product as well as the customer microservice. So let's first install it. Default project as product.microservice, and I paste this command, install package mass transit. We'll come back after these 3 packages are uh, already installed. One is mass transit, and another is mass transit.rabbitmq, and third is mass transit.ASP.NET Core. So guys, let's see, go to the this product microservices and manage NuGet package. Just see whether it is installed properly or not. Installed, let's see, mass transit.ASP.NET Core, mass transit.rabbitmq. All right, and these are the earlier ones that we have already built in the last 6 lectures. Now let's configure the mass transit in the product microservice, which is the publisher. And don't worry, I will be installing the mass transit packages also in um, the same mass transit packages in the customer microservice. But before that, I will just get through with the publisher microservice first. So let me close this window and bring the startup file for the product microservice. And in this startup file, I will just copy over the existing content with this content. So I'll just highlight everything and Control V to copy over my code. So you can see there are a number of using statements using mass transit, and these were already there. And then I could use this x.addBus, so services to the collection of services in the configure services method of the startup file, startup class. I have added the mass transit, and then this this lambda operator. To that lambda operator, I have used the add bus. This method is being okay. So anyway, it still works actually. So bus.factory.create using rabbit. So config, and then config.use health check provider, and then we are configuring the host with the username guest and the password guest. Okay, and then I am adding the mass transit hosted service. And other than that, everything else is the same. Add swagger is already added previously, and SQL Server is already added as well. So nothing else has changed. Now, since we are still using on the product microservices, in the controllers folder, I will create a controller, add controller. So this will be because it was not an MVC controller, it was an API controller. API controller empty. Click on add, and I will give this a name, customer product. Okay, so customer product controller. So public class customer product. Now in this um, customer product controller, it's I will write this controller append customer product controller, and actually let me highlight the entire thing, and then sorry, now I have created the controller by pasting the code with me. Now here you can see that I am using a dependency injection of ibus type, which is coming from the mass transit package. Okay, and where it is written that if you look over the IntelliSense, it says that a bus is a logical element that includes a logical local endpoint and zero or more receive receive endpoints. Okay, so I have injected the ibus or bus service. Now here, what this create product, which is of a HTTP post type, which is post type, so it is creating a product. Now, if the product is not null, then it is giving a date, product dot added on date, date time to today's date, I mean current date, current time, and it is creating an URI. So this URI is important. It is RabbitMQ colon backslash, which is localhost product queue. That means I am actually creating a product queue with this URI, and then I'm creating an endpoint which is asynchronously created, and it uses the get send endpoint, and it passes the URI which has been created over here, and then it is awaiting on endpoint.send. It's all coming through the this mass transit. Okay, so and it is returning true, and if the product is not null, then it will return false. Okay, if the product is already there, it is not added. If the product is not there, if product is not null, if this customer product is there, then it does this thing, and if the product is null, it returns false. Okay, now we'll configure the mass transit packages in our customer microservices. So what we'll do, we'll again open the package manager console, tools, and then NuGet package manager console, and then this time the default project is customer.microservice instead of product, and then just paste, install package MassTransit. We'll come back again once this is installed. Okay. Now visiting the customer microservice NuGet package manager. So manage NuGet packages, install. Let's see, MassTransit, MassTransit.asp.core, MassTransit.RabbitMQ. So all of these three MassTransit packages are included in both the projects. Okay. Now after that, we'll add a code to replace the existing default code in a class. We'll have to create a folder first in this this customer microservice, which is going to be acting as the subscriber or consumer. We'll create a folder customer consumers. So add a new folder, consumers, and then we'll add a new class within this consumer, which is called product consumer. So click on add class, product consumer. Okay, and paste the following code. Now I am into the product consumer class, and let's get rid of this code and paste our code, which is like this. It is still using mass transit, and remember here we have to use shared models. Okay, shared models.models folder. So because in the shared models we had the customer product. Now this product customer, this new class, it is implementing iConsumer. iConsumer is a class for this mass transit, and it defines a class that is a consumer of a message. Okay, and it is passing the customer product, which is what we have created here earlier in the shared models folder. So getting back there, what it is doing, it is actually asynchronously, it is um, calling a consume method. Okay, and where I am passing a consume context and passing it the customer product, which is just a context, which is a consumer context or context in terms of the consume. Let's see what the default um, mouse over says. It is just an interface. Okay, so let's see the definition. Go to definition, consume context. Okay, so this actually it derives, it implements so many other thing, consume context, so many other interfaces. Okay, and it actually gives us, it takes a T, which is a generic type of message, and it actually has got notify consumed and notify faulted. If it is consumed, then it is notifying as consumed successfully, or it is notifying as faulted. So this is getting implemented, consume context. Okay, so um, consume context, and here it is await task.run. It is running a task, and it is passing the. Now then, this product consumer class, as you can see that it actually derives, it implements iConsumer. So this iConsumer class, let's also see iConsumer class and go to the definition. See iConsumer, this is not a iConsumer, this is an interface, of course. And in T message, it actually, it colon iConsumer where T message equals class. So this is a generic class T message class. So this is substituted over here. This is a class, and an iConsumer has got only one, um, the signature of one method consume, which takes in a consume context T message context, and it returns a task, which is what it does actually. It returns asynchronous task, and it takes a consume context of customer product and it is now implemented over here, like task.run. So you're running a task, actually a task that represents the work queued to execute in the thread pool, and it is declaring an object which is context.message. So message is the one of the property of this context, which is a customer product context. So now if you click on the right click and see the definition, you can see that it has got T message type, which is notify consumed. A T message, it comes from the interface consume context. Okay, out T is the output parameter of type T is message. Okay, and it notifies that the message has been consumed. Note that this is internal and should not be called by a consumer. Okay. Now the last thing to be done before we test is the startup class of this consumer microservice, which is the customer microservice. We'll change the startup class to consume this MassTransit package. So I will just highlight everything and um, change the default code with the change the earlier written code with the following code. So Control V. So it has got MassTransit is added, and similarly this is on the consumer service. This is the subscriber for this uh, message, and it is actually a little bit different here if you put both the startups in together. So let's see, put both of these in a vertical document group. So you can see here uh, this was like services.add mass transit. That part was the same. And then X, this is the lambda operator, X dot add consumer. Here it was X dot add bus. Here it was you were adding a bus to create a connection and create the endpoints. Okay, but in this case here you are adding a consumer of type product consumer. Okay, and you're then adding a bus as well, X dot add bus provider bus dot factory dot create using Rabbit. So this part is actually the same. So use health check. So here basically this part is the same common, but only you are adding a consumer which is additional, and also you are receiving the endpoints. Over here you are configuring the product queue which you are creating over here from the publisher, which is the product microservice. You are creating a product queue which was produced in this class, in this controller, customer product controller, in the create product action method. You are setting up this product queue. So this was now you have got an endpoint or a customer as a consumer to consume that product queue. So the receive endpoint at this side, at the receiving side, is actually calling this receive endpoint method, and it is um, getting a product queue, and then these are the message retry and then configure consumer. So these are internal configuration things, and it is basically to configure the receive endpoint with the product queue. Okay, and then now our testing comes. So the summary of this part of this startup class for this consumer or the customer microservices, that it adds a new consumer, product consumer, and sets the host URI path with the guest credential, and it then sets the receiving endpoints for queue name product queue. Okay, so let's test it. So we'll be testing two scenarios in which the publisher and consumer are both online, meaning both the product and customer microservices are running. Now let's first build this application. So let's build this solution. So build succeeded. All of our 4 projects are now built successfully. So we'll go for the first case. Now for the first case, what we'll do is we'll have to create um, go to the properties, solution properties, and make both the customer and the um, product microservice as startup objects, multiple startup projects. Okay, and click on OK. So you've got these three options: start, none, start without debugging. So I'll make it start. Starts. I don't want this to start. So shared.models and gateway web API shouldn't take participate in this action to start. Now, before testing, before running the application to show the communication between these two microservices, I have just cleaned up a bit and I have just kept two tabs open. One is the product consumer. This is the um, on the customer microservice. This is the consumer. I will put a breakpoint over here as the subscriber, and I will put a breakpoint as the publisher over here. Okay, and let's see after running this application. So click on start. It will start up both the product as well as the customer microservices. Now, both of my microservices are up and running. I've shown customer microservice because it is just to show you that both the projects are running. And let me minimize this one, and we have got a customer product. So what I will do is I will create a body. I will form a body and post it by clicking try it out. So before that, I'll put another breakpoint over here, or basically this is should be returned true in order for this to be actually propagated to the customer. This is on the customer microservice side and this is on the product microservice. So we'll originate the message from the product side by forming this body. So let's write anything, the product name, say laptop or anything. ABCD, whatever you want. And this is the added on date, so it is automatically configured with datetime.now. And product description test. Okay, let's say test one. And price, anything, any price will do, 345. All right, and then click on execute. So that execution button will bring it to here. So you can see the product is not null. That's why it has got into this branch, and the product is added on this date, is 8/6/2021 at this time, price 345, test one, laptop, and which is what we have configured over here in this form body. Okay, now if you further click it, if you continue, it will hit this breakpoint and you can see that the message is already received over here. Price, product name, product description, and price, and case two where product. Now in this case, the customer microservice, which is the consumer microservice, will be down, which will be offline. And how we can do that? By clicking the solution property and making the customer microservice as none, with only the product microservice starting. Is click on OK, and if you click, it will only start the publisher microservice. So let the publisher or the product microservice come. Okay, so I will again expand this node, try it out, put something over here. Desktop, product description, my desktop, and price any arbitrary price, $1,200. Click on execute. Now remember, the product microservice is only available at the expense of the customer microservice. Now let us visit the Swagger and just see here. We still have this queues and product queue is there, and we have one message ready and unacknowledged 0, total 1. Okay, so total 1 message, in memory 1, persistent 1, and ready 1. Okay, and there are no consumers. Okay, and let's see the message. get messages. This time we are in for a surprise. We can actually see the message that we have configured for the this um, consumer microservice, which is the customer microservice to consume. My desktop price 1200, added 100 this one. All right, now so long as this is not consumed, this is available on the queue in the exchange, RabbitMQ. Okay, so we'll omit the channels and exchanges for the time being, but we'll concentrate on the queues and the messages. Now, to see how it is consumed, we'll stop the application and reconfigure again to run the customer microservice. So it will be started again. Click on apply. Okay, and then what I will do is in the product consumer class, I will click, and this already there is the breakpoint. So it will be hit without doing anything after I start the application. So I start the application. So both the applications are now running, and I will not do anything from the product microservice because it has already queued up one message for the customer microservice to consume. See, it has already hit this breakpoint without by doing anything on the product microservice. So you can see the message is here. My desktop product name is desktop, product description my desktop, price 1200. So now if you click on continue, before even continuing, let us see if the message is shown. Just let us reload this page, and we can see unacknowledged is still 1 because I have not totally acknowledged, and total is 1, consumer is 1 now. From 0 it has become 1. And let's see the get messages. Get message queue is empty. Okay, so it's no more there, that same message. Now if I run it to the completion, it won't change anything. He'll go back to the Swagger, and get messages queue is empty. You do whatever, you just refresh the page, it will be the same thing. So consumer is still 1, and there are no unacknowledged message, no message at all. It's all consumed. So queue is empty. So that marks the end of this tutorial. Here we have seen how we can use the RabbitMQ admin dashboard to configure our the async communication between the publisher and the um, consumer microservices. And we have actually created several test cases where the publisher has published a message which was consumed by the consumer microservice, which is the customer, with the publisher being the product microservice. Hope you like this, and if you enjoyed this tutorial, please do subscribe to my channel. Thank you.